Herzlich willkommen und guten Vormittag nach Österreich. Welcome also to our distinguished speakers and all who are joining us from India. Ich freue mich sehr, Sie heute zu unserem Webinar The Future of Greentech in India begrüßen zu dürfen. Mein Name ist Kerstin Beckel und ich bin derzeit die wirtschaftsdelegierte Stellvertreterin in Indien. Unsere Standorte in Indien sind nicht nur auf Neu-Delhi beschränkt, sondern wir haben auch Regionalbüros in Mumbai und in Bangalore. Weiters haben wir Consultants in Bangladesch, Sri Lanka, Nepal, Bhutan und auf den Malediven. Indien ist derzeit der drittgrößte Handelspartner für Österreich in Asien und über 800 österreichische Unternehmen haben bereits reguläre Geschäftsbeziehungen in Indien. Wir haben auch über 170 österreichische Niederlassungen schon hier vor Ort. Wenn wir über Indien sprechen, sprechen wir oft über Wirtschaftswachstum, Digitalisierung oder den neuen Fertigungsstandard. Doch immer stärker wird auch klar, Umwelttechnologie entwickelt sich hier zu einer strategischen und wirtschaftlichen Priorität für Viksit Bharat, ein entwickeltes Indien bis 2047. Und ein Blick auf die Zahlen zeigt uns auch die Dimensionen. Bis 2030 werden mehr als 600 Millionen Menschen in indischen Städten leben. Gleichzeitig entstehen aber bereits heute täglich über 160.000 Tonnen kommunaler Abfall mit einer Prognose von 165 Millionen Tonnen pro Jahr bis 2030. Dazu kommt die Herausforderung, dass Indien zwar 18% der Weltbevölkerung beherbergt, aber nur über etwa 4% der globalen Süßwasserressourcen verfügt. Und die Luftverschmutzung gehört in vielen Regionen zu den größten Gesundheits- und Produktivitätsrisiken überhaupt. Diese Zahlen zeigen aber nicht nur Herausforderungen, sie zeigen vor allem eines: den enormen Bedarf an innovativen Lösungen. Und die indische Regierung reagiert darauf mit gewaltigen Investitionen. Insgesamt investiert Indien jährlich 1,3 Milliarden US-Dollar in Infrastruktur, eine Größenordnung, die weltweit ihresgleichen sucht. Im Wassersektor wurde mit der Jal Jeevan Mission eines der größten Trinkwasserprogramme der Welt gestartet. Dafür stehen rund 95 Milliarden Euro zur Verfügung, um die langfristige Versorgung von hunderten Millionen Menschen mit sauberem Trinkwasser sicherzustellen. Auch im Bereich Kreislaufwirtschaft sehen wir einen Paradigmenwechsel. Seit dem 1. April 2026 sind die neuen Solid Waste Management Rules vollständig in Kraft. Sie verpflichten zur Mülltrennung, fördern Circular Economy Modelle und führen digitale Systeme zur Nachverfolgung von Abfallströmen ein. Damit entsteht auch ein völlig neuer Markt für Recycling, Sortier-, Monitoring- und Verwertungstechnologien. Gleichzeitig steigt auch die Nachfrage nach Lösungen zur Luftreinhaltung, Emissionsmessung und industriellen Dekarbonisierung. Unternehmen und Städte suchen zunehmend nach Technologien, die Umweltziele mit wirtschaftlicher Effizienz verbinden. Besonders beeindruckend ist auch die Entwicklung im Energiesektor. Indien hat seine installierte Kapazität erneuerbarer Energien innerhalb von 12 Jahren verachtfacht. Heute stehen wir bei rund 289 Gigawatt. Bis 2030 sollen 500 Gigawatt erreicht werden. Hinzu kommt zusätzlich ein ausgesprochen positives politisches Momentum. Das EU-Indien-Freihandelsabkommen, welches Anfang 2027 in Kraft treten soll, sowie auch der Besuch des österreichischen Bundeskanzlers und des Wirtschaftsministers in Indien vor Ort im April dieses Jahres, unterstreichen die strategische Bedeutung der Beziehungen zwischen Österreich und Indien. Zusammenfassend möchte ich sagen, dass Indien Umwelttechnologie immer weniger als reinen Kostenfaktor betrachtet, sondern zunehmend als strategische Voraussetzung für Wachstum, Lebensqualität und globale Wettbewerbsfähigkeit. Und genau darin liegt in unseren Augen die Chance für österreichische Unternehmen, denn viele der Lösungen, die Indien heute sucht, werden bereits von österreichischen Unternehmen erfolgreich entwickelt und eingesetzt. Und damit möchte ich Ihnen spannende Einblicke wünschen, neue Geschäftsperspektiven und eine inspirierende Diskussion. Now I will switch to English, and without further ado, I would like to hand over to Mr. Ajay Singh, our moderator for today's session.
Thank you, Kerstin, for the wonderful opening. And it is my honor to be joining with this webinar as a moderator. And from my side, good morning from the audience in Austria and good afternoon to the ones joining from India and rest of the world. Today, we have a very interesting webinar. We have industry speakers from the government, from the policymakers, from the industry, and as well from the startup side. Some house rules. We will have the webinar in English, and we will also listen to the presentation one by one. And this webinar will be recorded and uploaded on our YouTube channel. So you don't have to click the pictures or record anything. We will send you all the information afterwards. And without further ado, I would like to invite our very first speaker from Government of India DPIIT, Shri Pratinder Singh Padda, to make the presentation. Over to you, Mr. Padda.
Yeah, good afternoon, everyone. First of all, I'd like to apologize on behalf of Dr. Jayaprakash Shivhare. He was supposed to give this address, but due to some unavoidable circumstances, because of the parliament session, he had to go at the last moment.
Excuse me, Mr. Padda, your camera is not visible to us.
Okay, sorry. Yeah, can you see me?
Yes, please go ahead. Yes.
So he was incredibly excited about this keynote, and I am honored to step in on his behalf. So the presentation will start, and my address will be corresponding to the slides which are being shown on the channel right now. So, distinguished representatives of the Austrian Federal Economic Chamber and Advantage Austria, representatives of Austrian and Indian industry, colleagues from government, members of the research and innovation community, ladies and gentlemen. It is a pleasure to join you all for this discussion on the future of green tech in India. At the outset, I would like to thank Advantage Austria for organizing this timely webinar and for bringing together policymakers, industry leaders, technology providers, researchers, and innovators from India and Austria. The subject of today's keynote, Sustainable Industrial Infrastructure and Solutions for Environmental Mitigation, is central to India's development journey. It is also especially relevant to the evolving partnership between our two countries. India and Austria marked 75 years of diplomatic relations in 2024. Prime Minister Narendra Modi's landmark visit to Vienna that year, followed by Chancellor Christian Stocker's visit to India in April this year, gave fresh momentum to cooperation in green technologies, infrastructure, innovation, trade, and investment. It is therefore appropriate that we meet today not merely to discuss the promise of green tech, but to consider how Indian and Austrian capabilities can be brought together to address real industrial and environmental requirements. Ladies and gentlemen, as India advances towards Viksit Bharat by 2047, our goal is not only to expand manufacturing, but to make it globally competitive, resource efficient, and environmentally responsible. The challenge is to industrialize at scale and speed while using energy, water, and materials more efficiently and building resilience for future. When we traditionally think of industrial infrastructure, we think of lands, roads, electricity, water, and logistics. These will, of course, remain essential, but the industrial infrastructure of the future will be expected to do much more. It must help industries reduce the energy and water required for every unit of production. It must promote the use and recovery of materials. It must make modern environmental facilities accessible not only to large enterprises, but also to micro, small, and medium enterprises. And it must use digital systems to improve both operational efficiency and environmental performance. In other words, sustainability cannot be treated as a corrective measure introduced after an industrial project has already been designed. India is capitalizing on this opportunity precisely. More than 4,200 industrial parks have been mapped through the India Industrial Land Bank, the national digital platform through which investors can examine industrial locations together with information on land, connectivity, and supporting infrastructure. India is also developing 20 industrial smart cities and areas under the National Industrial Corridor Development Program. These are planned manufacturing locations intended to combine industrial land with modern transport, utilities, logistics, and urban infrastructure. Alongside this, PM Gati Shakti, India's national digital platform for integrated infrastructure planning, is enabling ministries and public agencies to plan roads, railways, ports, logistic networks, and industrial development with greater coordination and better use of geospatial data. The recently approved Bharat Audyogik Vikas Yojana or Bhavya is another important step in this direction. With an outlay of more than 3 billion euros, the scheme envisages the development of 100 investment-ready industrial parks over the next 6 years. The objective is not merely to provide industrial land, but to create integrated ecosystems with multimodal connectivity, reliable utilities, digital systems, worker facilities, and sustainability built into their design. Shared infrastructure is especially important for smaller enterprises, which may find advanced wastewater treatment, energy management, and material recovery systems costly to develop independently. Common facilities can reduce costs, improve reliability, and make modern environmental solutions more widely accessible. Now, three transitions will shape the future of sustainable industrial infrastructure in India. The first is the transition towards cleaner and more efficient industrial energy systems. India has made significant progress in expanding its clean energy capacity. As you can see on the screen, non-fossil sources now account for 54.18% of the country's installed electricity generation capacity, with approximately 162 gigawatt of installed solar capacity and more than 57 gigawatt of installed wind capacity. This represents a major expansion of India's clean energy base. However, installed capacity is only one part of the equation. A modern manufacturing facility requires power that is not only clean, but also reliable, affordable, and of the quality required for sophisticated production processes. The next generation of industrial infrastructure will therefore increasingly need to combine renewable energy with storage, smart electricity networks, energy-efficient industrial equipment, digital demand management, and waste heat recovery. For industrial processes that are difficult to electrify directly, green hydrogen, biogas, and other low-carbon fuels may also play an important role. The opportunity before us is to connect India's expansion in renewable energy more closely with its expansion in manufacturing. The second transition is from linear resource consumption towards greater circularity, one that keeps resources in use for longer and recovers value from waste. Treated wastewater, for example, can support industrial use, organic waste can be converted into biogas, and materials and industrial byproducts can be recovered, reused, or redirected into other productive processes. Water security is a particularly important part of this transition. Across India, cities, industrial development agencies, and businesses are expanding the treatment and reuse of wastewater. Under Amrut 2.0, the government's national mission for strengthening urban water supply and sewerage systems, cities have reported that approximately 6.535 million liters of treated water are already being reused every day for applications including industry, agriculture, and horticulture. For industry, wastewater reuse is both an environmental responsibility and a source of operational resilience. The same circular approach should guide industrial waste management. At the cluster level, byproducts from one process can become input from another, while shared recovery facilities and digital traceability can improve efficiency and accountability. India has also strengthened extended producer responsibility frameworks for plastic packaging, electronic waste, tires and batteries, supporting greater collection, authorized recycling, material recovery, and circular use of these resources. The third transition is from periodic compliance to continuous environmental performance. Digital monitoring can track energy use, emissions, water consumption, and waste in real time, helping industries detect inefficiencies early and strengthen compliance and reduce operational costs. Better data is therefore becoming essential to both environmental governance and industrial competitiveness. This transition will also be reinforced by India's emerging carbon market architecture. Under the compliance mechanism of the Indian carbon market, designated energy-intensive industries must meet targets for reducing greenhouse gas emissions per unit of output. Such targets currently cover 490 obligated entities across 8 sectors that are aluminium, cement, chlor-alkali, pulp and paper, petroleum, refining, petrochemicals, textiles, and secondary aluminium. Companies that outperform their prescribed targets may earn tradable carbon credit certificates, while those that fall short will be required to meet their obligations under the applicable framework. As this system develops, credible measurement, reporting, and verification will become increasingly important. Businesses that can demonstrate lower carbon intensity and improve resource efficiency will be better positioned to participate in sustainable supply chains, attract responsible investment, and respond to the expectations of customers in India and abroad. Ladies and gentlemen, these transitions create a particularly strong basis for deeper cooperation between India and Austria. Austria has built a globally recognized environmental technology sector comprised of more than 3,300 industrial and service companies, employing nearly 58,000 people, and with a combined turnover of approximately 21.4 billion euros, more than 80% of which was exported. Importantly, Austria's strengths are closely aligned with the challenges India is seeking to address. Its environmental technology sector has developed deep capabilities in renewable energy, energy efficiency, water and wastewater management, recycling, and industrial process optimization. These are not niche activities. Together, energy-related technologies account for a substantial share of the sector sales, while water and circular economy solutions remain important areas of Austrian expertise. India offers the scale and industrial capacity to adapt and commercialize these solutions. Medium and high technology activities account for 46.3% of India's manufacturing value, while engineering goods exports touched a record 106 billion euros in financial year 2025-26. India also has more than 223,000 DPIT recognized startups, providing a substantial base for technology adaptation, digital integration, and new service models. The opportunity is to combine Austrian environmental engineering with Indian manufacturing, software, project execution, and service capabilities to localize solutions for industrial energy efficiency, water reuse, recycling, and environmental monitoring, and scale them in India and other emerging markets. This is not a partnership that begins today. Around 160 Austrian companies are already operating in India. Bilateral trade has crossed 2 billion euros and have invested nearly 650 million euros since 2000 itself. Our institutional framework for cooperation is also stronger than ever. The 17th India-Austria Joint Economic Commission, held in New Delhi in April 2026, identified opportunities across trade and investment, infrastructure, research, skills, startups, semiconductors, critical minerals, digitalization, and artificial intelligence. The India-Austria Startup Bridge, established by Startup India in partnership with the Advantage Austria, is helping connect startups and innovation ecosystems in both countries. The new bilateral fast-track mechanism provides a dedicated channel to identify and resolve issues faced by Indian and Austrian companies operating in each other's markets. We should now use these platforms to convert shared priorities into practical investments, technology partnerships, and commercially scalable projects. In this context, I would like to offer 4 broad propositions. First, we should promote integrated solutions that bring together clean energy, storage, water use, resource recovery, and digital monitoring across industrial parks and clusters. Secondly, combine Austrian technology with Indian manufacturing, engineering, software, and service capabilities to localize these solutions and improve affordability and jointly serve wider markets. Third, Greentech must be made more accessible to MSMEs through shared infrastructure and commercially viable performance-linked models. And lastly, partnerships should include skills, maintenance, and knowledge transfer to ensure that technologies deliver sustained results. As the Department of Promotion and Industry and Internal Trade, our role is to facilitate investment and create an enabling environment for such partnerships. We encourage Austrian companies to view India not only as a market, but as a base for innovation, manufacturing, localization, and global growth. Let us now translate dialogue into investment, integrated solutions, and scalable partnerships, building infrastructure that is competitive, sustainable, and future-ready. Thank you. Jai Hind.
Thank you very much, Mr. Singh Pagda, for your wonderful presentation. I'm sure the audience will have some questions afterwards. For the audience joining, we can have the Q&A at the end. I would ask you to post your questions in the Q&A section, and at the end, I will read out to the speakers you asked for. And now we move from the government of India from the government to the policy side of it. And I invite Dr. Sunil Pandey from TERI to make the presentation. Over to you, Mr. Pandey.
Advantage Austria for providing me platform here. And my presentation is titled as, go to the first one, Environmental Challenges of India's Economic Growth and Remedies. And some of these also echoes with the earlier presentation by Mr. Padda, very interesting presentation. Next one. So the region, as you know, has seen very high level of economic growth. including India and other countries in the region, and which has, as a result, lifted a lot of people out of poverty. And many of our development goals, though, because of recent geopolitical developments, we have some setback, but mostly within the region cannot realize its promise, however, by following the conventional growth strategies, which was till date largely fossil fuel based, but we are making a transition there. Resource constraints, price volatility, and climate crisis, however, requires a re-examination of some of our resource-intensive and carbon-intensive growth strategies. Next one. So looking at in Indian context, what we've seen is in terms of climate gas emissions, we remain third largest GHG emitter, and because of huge dependence on fossil fuel. But if you look at per capita, we are still very low, around 1.9 tons per capita per year. So, but we have responsibility, and we have taken that responsibility. Rapid urban and industrial expansion has led to deforestation, loss of biodiversity, and rising pollution. If you look at NITI Aayog, as per their report, one of the premier planning institutions in the country, in terms of solid waste, we are now generating around 101 million tons of waste we generated in 2024. Of this, around 61% ended in landfill, and the remaining primarily went through process of treatment and incineration, generating energy from the waste. On the wastewater side, also, we an estimated 173 million liters of day of wastewater was generated in 2020. Of this, the collected sewage, 55% remains untreated due to paucity of infrastructure. And much of the treatment facility still depends on aerobic treatment solutions. 63%, 64% around of the wastewater treatment plants are based on aerobic solutions. And but good to know that 36% of the wastewater treatment plants also have shifted to anaerobic processes, which also results in resource recovery. So this is where the opportunity lies. The next one. In terms of now, we'll discuss one by one the pollution which we have been facing and what we in the end what we have been doing with different pollution aspects. IQ Air, a Swiss-based organization, ranks India as 5th worst in the world in terms of air quality, behind countries like Chad, Bangladesh, Pakistan, and Democratic Republic of Congo. 35 of the world's 50 most polluted cities are in India, driven largely by industrial activities and vehicle emissions. Delhi has consistently recorded some of the worst air qualities in the world, with annual PM 2.5 levels many times above the WHO standard. And there is an interesting study which also notes that Delhi, air pollution in Delhi costs 5.8% of its annual GDP loss through reduced worker productivity and rising health costs. Next one. Next one. In one of our studies for a neighboring state to Delhi, which is called Uttar Pradesh, we did exercise looking at what are the major sources of air pollution in the baseline year of 2020. And as you know, I mean, this whole region actually falls in Indo-Gangetic Plain. And Indo-Gangetic Plain not only is in India, but also extends beyond. Is the major causes for air pollution are domestic and commercial reasons, small industries, agricultural waste burning, agricultural secondary sources, transport emissions, road dust, and waste burning. So some of these we extensively working on with World Bank support. The state is working on how to reduce these pollution sources and how to basically come out with lower emission levels. Next one. In terms of water pollution, we have made some progress. There are various river cleaning action plans out of, say, for example, in 2015, we had seen 275 of the 390 water stretches were identified as polluted. whereas in 2022, this has reduced to 46%. Now only 279 of 603 stations monitored source pollution. Water pollution, as you know, is in India is associated with 9% drop in agricultural revenues and 60% increase in downstream agricultural use. So it's a serious issue. One needs to we are also looking at this. While waterborne diseases still remain a concern in marginalized population across the country. Next one. So to address these, some of these also have been mentioned in the earlier presentation, but I'll still would like to repeat these. There is a continued thrust on developing renewable energy resources, enhancing energy efficiency in the industry sector, developing climate resilient urban centers, sustainable green transportation, focus on EV electric vehicles, Swachh Bharat mission, looking at improved sanitation, including waste management, and Make in India program. Sustained afforestation in the country has also helped recover some of the lost forest cover in the recent years, and apparently we are moving in the right direction. Country also aims to meet 50% of its energy need from renewable sources, as said earlier, reach 500 gigawatt of non-fossil fuel capacity by 2030, and cutting carbon emissions by 45%, carbon intensity by 45% as committed. Achieving this would mean major shift towards solar, wind, battery storage, and grid modernization. But however, we are also aware of issues that end-of-life assets at some point of time, maybe 15 years, 20 years down the line, they will also have to be addressed, and subsequently also developing recycling and recovery technologies. And that is where also there's a opportunity in collaboration. In 2019, under our air quality program, we also introduced a target for reducing current air pollution levels to 20 to 30% in 100 cities by 2024. The plan has been recently updated to achieve 40% reduction by 2026. And Ministry of Jal Shakti, as said earlier, has also come out with a national framework for increasing reuse of treated water. In fact, some of the states and some of the urban local bodies, this has become major revenue sources for them by trying to by treating the wastewater and selling it to industry for their process and non-process use. And then there's a government's flagship program called Lifestyle for Environment, Mission Life, basically to reduce consumption level at the individual by the individuals, so that overall consumption levels can be reduced. So with this, I'd like to end my presentation. Thank you, and I'll join you in the question answer session later.
Thank you very much, Dr. Pandey, for your wonderful presentation. And without any further delay, I would like to invite our next speaker, Dr. Harsh Sethi, founder, Trinano Technologies, to make the keynote. Over to you, Dr. Sethi.
Yeah, good afternoon, good morning, wherever you are in Austria, Advantage Austria and the team. Thanks for giving me the opportunity to speak at this August forum where eminent speakers before me have talked about the solar energy or renewable energy future in India. I am currently going to talk about the current challenges and future of solar energy. So going to talk about India energy sovereignty and how does the innovation can help in navigating the challenges and meeting the requirements for energy sovereignty. Next slide. So my personal background, I'm a materials engineer, a PhD, and I am the CEO co-founder of Trinano Technologies. We are incubated at IIT Bombay, which is a premier institute in India. And with our 3D quantum cladding patented technology, we are working towards improving the energy output of any and every solar panel and working towards the energy independence of each and every country. Next slide, please. So when we talk of current geopolitical scenario, India is facing those shocks because we are close to the Middle East, Strait of Hormuz. But while you are in Austria, you are facing the shocks because of the war between Ukraine and Russia. And that has affected every country because we are in a way dependent on the energy supply chain. And therefore, the shift has been from a green tech independence to actually and from environmental aspiration to actually urgent national security issue where we need to have energy sovereignty with our own independent and in-house resources. Next slide. So when we talk of India in particular, we are having our 88% of our crude oil imports and 60% of our LPG requirements passing through the Strait of Hormuz, which is a major block point. And because of the recent issues there, the oil prices have gone up $120 a barrel. And the LPG import cost also has risen by 46%. So that has affected the macroeconomic risk, and India has to look at alternative sources of energy. The government has been working in that direction since quite some years, but the focus has been more pronounced now in light of these issues. We need to work on what are our current sources, how to best use it, and then what are the efficiency improvement we can do it by way of innovation in the industry, in the sector. Next slide. So when we talk of India, the drivers are that we are targeting around 500 gigawatt of non-fossil renewable energy capacity by 2030. And we have been achieving that every year, rather overachieving it every year. We are looking at offsetting the carbon emissions by 45% below the 2005 levels and cutting down by 1 billion tons by 2030 and achieving the carbon neutrality by 2070. The government and all the stakeholders are also working towards accelerating India's industrial electrification and replacing imported transport fuel with domestic electric power and green hydrogen. So there is a continuous push on the green energy side from the national drive point of view. Next slide. So the government is working in terms of solar. Government is working to mandate that manufacturing is done in India rather than for oil and gas. We are depending on the Middle East, but for solar, traditionally we have been dependent on the imports from China. The panels were imported from China. So slowly government started mandating that we have to build in India, made in India technology. And therefore, first came approved list of module manufacturers where even though the cells were imported, but they were assembled in India. Then slowly the government realized that cell is again a very critical factor in this manufacturing, and therefore domestic content requirement came in, and also a requirement came in for approved list of cell manufacturing, wherein the cell must also be made by Indian manufacturers. And that was done for maintaining our energy sovereignty and made in India target of all these critical items. So for that, with that in mind, government started promoting production link incentive and giving the loans, subsidized loan to all the manufacturers who wanted to set up the back integration from cell to panel, and even back from ingot cutting down to wafer, wafer to cell, cell to panel. So that integration is supported by government through PLI scheme, and expansion is also supported by government through approved list of cell manufacturers. So if somebody is bidding for a government project or some government schemes, then they have to qualify in approved list of module manufacturers, approved list of cell manufacturers, and also qualify for the domestic content requirement. So thereby, government is trying to see that the content remains in India, and we start promoting made in India technology and serve the world. Next slide. Now, there are challenges to that because currently India is manufacturing around almost 200 gigawatt of panel manufacturing, but the cell manufacturing remains around 31 to 35 gigawatt only. So there is an acute shortage of cell manufacturers, and therefore the government there is a big demand, supply and demand, there is a gap. So government is promoting that cell manufacturing be done, and therefore there are a lot of schemes available. Then there are, once the panels are made, then in Indian conditions, when we are putting up the solar energy, there are challenges regarding to aggressive degradation and thermal losses. So India, because in the zone of Tropic of Cancer in Capricorn, we get a good sunlight, but that also means that the temperature goes above 25 degrees, which is supposed to be the ideal temperature for solar panel. It goes above 25, goes up to 40, 45. Now in Europe also you have 40, 45 degrees centigrade. That causes degradation and thermal losses. Then in India also we have issues of dust, oil, grime, bird droppings. Similar, you may not have dust in Austria, but then bird droppings and other environmental issues may be there. So that also causes soiling losses. Now for that we need regular maintenance and cleaning, which becomes a typical challenging factor in India, where in certain parts of the country, drinking water is scarce. So getting a clean water for cleaning of solar panel becomes a big challenge. And therefore it causes escalation in operating and maintenance costs, or either reducing your output of the solar panel. Next slide, please. So that is where we come in. Innovation in the industry would help mitigate these challenges. And at TriNano, we are trying our bit to mitigate and work towards energy independence, improving the output and reducing the O&M costs. So what we have done is we have developed a patented solid state 3D quantum cladding nano coating, which works with any and every solar panel to increase the power output, reduce the cleaning frequency, use of water for cleaning, and also reduce the cell temperature, which means it increases the life of the panel. So this was done at the IIT Bombay laboratories, along with incubation support from IIT Bombay. Next. So how do we do that? Just in a brief shell, the technology has got properties of anti-reflection, self-cleaning, light trapping, and cooling effect, all 4 properties in one single coating. And the material is inorganic ceramic oxide material, and the coating is done by electrodeposition process. So we are very different from whatever is available today in the world. China is doing by dip method. There are a lot of coatings available which use paint spray method or organic coatings. So what the innovation is about, it's an inorganic ceramic oxide material and done by electrodeposition process. And the way we do the coating is we create on a subatomic level, on a nanoscale, a unique microstructure which resembles rain tree forest. So when light falls on it, it doesn't get reflected, it gets refracted or trapped inside. And that light, because the thickness is 0.3 micron, 1/3 the thickness of human hair, the light then is transferred to underneath solar cells. So they could be any make, type, age, or location. When they get more light, they generate more power or more energy to the extent of increase in power by 4 to 6%. Secondly, the structure is very sharp needle-like. So solar panels are always at an angle. The tip of the needle is 0.1 micron. Dust particles are normally measured by PM 2.5, particulate matter 2.5. So imagine on a slope, a ball-like structure sitting on the tip of a needle. It doesn't stick, it tends to roll down. So that's how we reduce the cleaning frequency and use of water. And for application of technology, it's a simple plug and play. You just need 220 volt power supply, ordinary household power supply. There is no requirement of any special setup, no clean room, no special HVAC conditions, no heating, baking, no surface treatment, no curing or drying time. And it can be done for panels which are being manufactured as well as panels which are already installed. So you may have panels on the ground ground-mounted solar panels or floating solar panel or rooftop C&I installations, the coating can be done there as well, because the equipment with which we do, it's a modular equipment and you can take it there. So it has already been granted in India, and anybody who's using the technology can get a ROI very fast in 24 to 26 months. Next slide. So with our customers who have used this technology, they have given the impact as 5 to 6% increase in power output immediately, reduction in water consumption for cleaning of solar panel by as much as 40%, labor used for cleaning or operation and maintenance reduction by 25%, because we reduce the cleaning frequency, and increase in the life of the panels by approximately 2 years. And the coating lasts more than 10 years. So there is no coating today in the world which can boast of 10 years life. Next slide. So what we talk about here is the financial and ESG impacts. Immediately you get a power output increase and reduce cleaning frequency. So ROI is just about 26 to 30 months. There is no surface pretreatment, heating or baking. So there is no hazardous waste or toxic emissions coming out. There is a drastic reduction in water consumption or water used for cleaning purposes. So it supports the corporate ESG and net zero targets. And because there is a cooling effect, so panels last longer. So there is an increase in life of the panels by 2 years. So there is increase in the circularity economy. Next slide, please. So when we talk of energy sovereignty right now, in India, we are talking of ALMM list of, and government has given an extension till 31st December. But after that, the modules and the cells have to be made in India. So by 2026, the DCR will come in full force. And then we are looking at by 2030, the 500 gigawatt non-fossil capacity and reduction in carbon emissions by 1 billion ton. And by 2070, we are looking at net zero emission achievement of the goal. Next slide. So with the innovation, like Tynano, there may be other innovation you may have. We have to harness the power of solar to the best efficiency possible, best productivity possible, and reduce O&M expenses. And thereby we can reduce the dependencies on fossil fuels, on imports, and be energy independent. So that's how we are contributing to that. And we would love to have any questions you may have, or work with any partners in Austria to this cause. Thank you.
Thank you, Dr. Sethi, for your wonderful presentation. And now I would like to again tell the audience to please prepare your questions at the end. After our last presentation, we will have the opportunity to ask those questions to the respective speaker. And with that, we also move to from the industry, academia, and corporate to the startup. And I would like to invite Dr. V.R. Rajesh, Vice President Onshore, to make the presentation. Over to you, Dr. Rajesh.
Thank you, Ajay. So good afternoon, good morning, distinguished delegates joined this webinar, and representatives from the Austrian Embassy, Commercial Section, and the fellow leaders in the green technology. Thank you for having me today. My name is Dr. V.R. Rajesh, and I'm thrilled to present a topic that sits at the very foundation of climate resilience and green technology, which is hyperlocal climate data. At Orashore, we believe that you cannot manage what you cannot measure. Today, I want to take you through why hyperlocal data is no longer luxury, but the baseline infrastructure of any sustainable climate resilient future. When we talk about the India is one of the most microclimate diverse regions on the planet. In a single metropolitan area, temperature can vary by 4 to 6 degrees Celsius due to urban heat islands effect. AQI can spike from moderate to severe within distance of just 2 kilometers because the localized industrial output, heavy traffic, or construction dust. That is why climate risk cannot be understood only at the national, state, or city level. In India, a flood-prone junction, a heat-stressed ward, an industrial corridor, and a school zone can each have a completely different environmental reality on the same day. Historically, climate and weather monitoring relied on sparse macroclimatic stations or satellite data often placed many kilometers apart. While macro data is useful for telling whether you may need an umbrella tomorrow, but it is not enough for operational decisions for industries or the government. It is inadequate for city managers to trying to prevent localized flash flooding and industrial plant manager managing a particulate emission at a dust hotspot, or a renewable energy operator planning around macro irradiance and a cloud cover. Macro data leaves the blind spot in a rapid growth economies like India and across the global south. Those blind spots translate into economic losses, health hazards, and unmanaged climate risks. At Orasure, basically, we bridge this gap between the macro climate models and ground level reality. We have built an end-to-end AI-powered climate intelligence ecosystem. Our solutions not just have a software layer, and it is not just a hardware. It is a vertically integrated stack where an IoT hardware, edge AI calibrations, and reliability of AI-driven analytics, SaaS, dashboard, APIs, and continuous risk monitoring is taking place. We design and deploy multi-parameter environmental sensors that continuously stream real-time data on air quality, weather parameters, heat stress, and flood risk. Our calibration and analytics layers then transform that raw telemetry into sector-specific dashboards, predictive warnings, and decision-ready insights. On talking about the entire hardware stack, if you see, we touch upon different aspects of the businesses. So for example, our Orasure Infra, Orasure Trust are the industrial grade air quality monitoring systems which are used from industries, smart cities, or construction sites. Orasure Care is an indoor air quality device which lets the people measure the indoor air quality, gases, and other parameters. Orasure Echo and Orasure weather stations helps to prevent flood monitoring and disaster management. And all of this, since it is entirely made in India, we can customize based on the specific state country requirement. Now, talking about the entire layer, we focus on 4 core risk pillars: air intelligence, urban heat intelligence, flood early warning system, and hyperlocal weather intelligence. Air intelligence tracks particulate material and gases in real time, making pollution sources and exposure pattern visible. Heat intelligence identifies the heat stress and urban heat pockets, which is increasingly important as cities become denser and nighttime cooling declines. Flood intelligence track rainfall, water levels, and rising risk so that alerts can move faster so that the flood water can be taken care. Weather intelligence gives hyperlocal operational visibility for rainfall, wind temperature, solar radiation, and microclimatic change. Together, these modules convert environmental signals into one decision layer. As of now, in last 3.5 years, we have proven our technology at serious scale. To share few key numbers, we have deployed over 4,000 smart environmental devices, covered 350 plus cities, and our infrastructure has ingested and processed over 10 billion data points in 10 plus countries. While India is our proving ground, climate risk is global. Orasure's footprint extends across multiple countries with expansion into Latin America and Brazil. The important point is the technology developed for complex, high stress environment in India translate naturally to other climate vulnerable geographies across the globe. Now talking about the industries, and we talked about the different segments we serve. Smart cities and municipal bodies with the government uses to identify the urban heat pockets, trigger air pollution responses, and build flood early warning system for vulnerable cities. We also work with heavy industries, mining and manufacturing to use them to monitor real-time emission, protect worker health and safety, and automate the ESG compliance reporting. We work with infrastructures and logistic companies who uses our solutions to our highway corridors, port construction sites, and large infrastructure projects. We work with ESG, health, and insurance enterprises using the ground truth data of ours to back the climate insurance, underwriting, green infrastructure planning, and enterprise ESG enclosures. We are proud to work with leading partners enterprises, including Google Maps, Honeywell, Jindal, Powers, ICLEI, are key government agencies where we also provide our solutions in terms of hardware and data. What we what actual impact of the hyperlocal data is, it helps organizations to move from reactive to preventive. Instead of reacting to a flood or a severe pollution event after it happens, early warning models can give the government and the industry's safety managers to minute to hour to lead time to protect lives and assets. It also democratizes environmental data. By working with organizations like ICLE and ecosystem partner like Google, AirView Plus projects, live environmental metrics can reach public dashboards and awareness systems, turning raw data into community-level environmental visibility. Finally, it builds climate resilience by helping place green infrastructure and investment exactly where vulnerability is highest. This has been last 4 years of our journey, and we are basically I've covered all these points, and we are also looking to expand into the European market. These are the couple of customers with whom we are currently working, which include from India to the Latin American and the African market. Now, coming to most importantly, why we are here today is basically why we believe Austria could be a major market for us. Austria is internationally recognized for engineering excellence, as my previous speakers mentioned. Environmental leadership and innovative green technologies India offers at unprecedented scale, rapid urban transitions and dynamic technology ecosystem can be a good match. When Austrian green tech solutions, whether in urban planning, renewable energy systems, industrial automation, water systems, or circular economy, are paired with Eurasia's hyperlocal climate intelligence, we create smarter, data-driven solutions. This is the synergy the European environmental precision meeting Indian operational scale. To my last slide, my call to action is basically we are actively looking for partners in India and globally system integrators and solution providers in Austria and Europe who want to embed hyper accurate climate monitoring into their projects. We will be happy to connect with them and to see how we can take this forward together. If you want to hear from us more about Eurasia's work, please do connect with us and we'll be happy to take this discussion forward. Thank you so much, Ajay, for the opportunity and the Advantage Austria team, and looking forward for the questions and answer session. Thank you.
Thank you, Dr. Rajesh, for the wonderful presentation. And quickly, running out of time we are quickly moving to the Q&A session. To all the speakers, please turn on your microphone and camera, please. We have time for 1 or 2 questions. So I would ask, I will summarize these questions in one mega question. So most of the companies say India is a huge market, and sometimes it's overwhelming and they are not quite sure where to start and which clusters, which sectors. In your opinion, what would you advise to the Austrian companies, which sector clusters they should look? And second part of the question would be what help they can expect from your respective organization. So I would address this question to maybe first to Dr. Pandey to address the question.
Thank you, Ajay. And as I presented earlier, there's a huge opportunity in wastewater treatment and reuse. Going the anaerobic way where, some resource recovery in terms of energy is possible. So, and we can be your local knowledge partner for the issues. We also have been working on a framework for recycling end-of-life assets in solar and storage batteries and also EV sector. So we can also act as a knowledge partner to your queries and requirements. So I'll stop here.
Thank you. I will move to Dr. Sethi on the same question, please.
Yeah, so we are actually India also offers a good incubation and acceleration center, and where any company who's a technology driven, they can come in and partner with us or with others or with premier institutes to set up here and explore the Indian market and also the overseas market. So government offers good amount of support, also grants and other privileges, tax benefits, which should be in the light of what the company or the startup has an innovative idea and how it can help India at large and the world in general. So that is one part. On our part, we are open to partnerships. If somebody is looking for into renewable green energy, we are open to discussion in partnerships and also joining hands in JV agreements. Thank you.
Thank you, Dr. Sethi. Quickly, Dr. V. Rajesh.
So I think what my previous speakers mentioned, just to add, I think there is a lot of things happening across India and Austria. I think that's a great time to do. We're looking for joint pilot programs in India. We'll be very happy to partner with the companies working in ESG monitoring or occupational safety and research institutions, and we'll be very happy to collaborate with them, Ajay, through Advantage Austria.
Thank you very much. Thank you very much for all the speakers. Some questions I will send you directly on your emails. Thanks for joining the webinar today. Quickly, now I hand over to our Deputy Trade Commissioner, Ms. Kerstin Peckel, to make the final remark. Thank you very much.
Thank you.
Yes, thank you very much. Also on behalf of Advantage Austria, to our distinguished speakers from DPID, Government of India, TERI, the Energy and Resources Institute, Trinano and Eurosure, for giving their comprehensive overview on the future of Greentech in India, and also to share their tremendous expertise with the Austrian companies today. I would like to take the chance. Ich möchte gerne die Gelegenheit nutzen, die österreichischen Unternehmen auch auf unsere nächsten Wirtschaftsmissionen hinzuweisen. Wir haben für alle, die sich jetzt ganz kurzfristig entscheiden möchten, das, was Sie heute gehört haben, auch in Indien vor Ort zu erforschen und die Möglichkeiten einfach vor Ort zu ergreifen. Wir haben die Greentech India inklusive der IFAD in Mumbai von 7. bis 10. September. Anmeldungen sind noch möglich, um einfach Geschäftschancen vor allem im Recycling- und Abfallwirtschaftstechnologiebereich im bevölkerungsreichsten Land der Erde zu erforschen. Unsere Webinar-Serie geht weiter mit dem Future of Green Hydrogen in India am 22.09. und auch die Future of Railway and Metro Infrastructure am 29.09. Im November haben wir dann 2 parallele Wirtschaftsmissionen, einmal Schienenverkehr und Metroinfrastruktur und einmal die Zukunftsreise Technologie- und Innovationsökosystem, wo wir auch den Bangalore Tech Summit 2026 besuchen werden. Mehr Informationen und auch die genauen Programme finden Sie auf der wko.at Homepage unter Veranstaltungen Indien. Und dann bleibt mir nur zu sagen, wir freuen uns, von Ihnen zu hören und Sie auf Ihrem Weg nach Indien und auch bei Ihren Projekten in Indien bestmöglich zu unterstützen. Vielen Dank für Ihre Teilnahme.